Hello everyone. Today let's go over an easy question that I just solved by myself. This one I struggled with for a long time, but I was finally able to do it, so I'm very happy. I came up with my own solution. So let me show you. This one is actually a similar question to a grind 75 question, top K frequent words. If you're familiar with that, that's a heap question. So it's good to do that to get all around practice and to test that you've understood the core concepts. So this one's called maximum number of pairs in an array. So you're given a zero indexed integer array called nums, so a list, and you're basically wanting to perform as many operations as possible where you pick any two integers that are equal inside of the array, and you keep deleting them until you can't do this anymore. And then first of all, you want to count how many of these operations you can have, and then also how many are left over, because let's say that sometimes you cannot form a pair because the frequency of a number is going to be odd, like 2 appears 3 times, that's odd, so the leftover will be 1. Anytime a number with frequency is odd, then the leftover is going to be 1, even if the frequency is 1 itself. So if you know that, and you make some observations, let's go ahead and create a dictionary to get the frequency of every single element and also the element itself. And there's a trick in Python to do this called a counter. It makes it very quick and efficient. So let's print C. As you can see, this quickly gives you the number itself along with how many times it appeared in the array as the value. So very convenient. So 1 appears twice in the array and 3 appears twice in the array as well. So now, as I said, we want to basically count how many pairs we can remove. So let's go ahead and iterate over this counter object, and let's print the key and the value. So you can see, so 1 appears twice, 3 appears twice, 2 appears 3 times. And now, as we said, let's have a result. And to see how many leftovers we have, we are basically just going to add the frequency modulo 2, because if a value modulo 2 is not equal to 0, then it is equal to 1, then we do have a leftover, so 1 here. Otherwise, we're going to keep seeing how many pairs we can form, which basically just means divided by 2, because a pair is 2. So if we had 4 ones, then you can form 2 pairs. If we had 6 ones, you can form 3 pairs and vice versa. Here we have 2 ones, so you can only form 1 pair. And same with 3. There's only 2 3s, so you can form 1 pair. So let's call this pairs count. And we're going to add b divided by 2, because b, again, is the frequency divided by 2 is how many pairs we get based on the dividability of this frequency by 2. And at the end, we're going to have the leftovers and the pairs. So the pairs are the number of pairs that we could form based on all these numbers and their frequencies, and then the result is going to be the leftover. Let's call this pairs count. Let's use the same variable name, and as you can see, you get 3 1, 1 0, and 0 1. And so now we just return a list of pairs count with result. And we can run this and then submit it. And as you can see, it passes all the test cases. It's not the most efficient, but it is my own solution. So I'm pretty glad, because this is a grind 75 similar question. So it shows that I really understand the concepts. So I'm proud of it. This is O of n. So linear time, it could probably be a little more efficient, but this is intuitive and I hope it helped you guys. So thank you for watching and stay tuned for more content.